Hi, everybody. We're here. We're going to do, we're in Algebra 1, IXL, and we're going to be doing the section J4, sorry, solve two-step linear equations. So this is in J4 of IXL Algebra 1, and I'm going to show you the two-step linear equations. I'm going to solve some of these guys. Much easier than dancing two-step. All right. The first thing you want to notice is that W is being divided by 3, and then 9 is being added to it. The rule for algebra is to do the opposite to both sides in reverse order, and the reverse order is very important. Now, you could do this in either order. Now, a lot of times it's going to make it way harder to do it out of order. In this particular case, it really is about the same either way. Because W is being divided by 3 first, though, that's the last thing we want to do when we solve. We want to undo the steps. It's a bit like this. Putting on your socks would be the dividing by 3, and then putting on your shoes would be the adding 9. Clearly, you probably want to take the shoes off before you try and take off the socks. So we've got W, sorry, my pen going. So I have W divided by 3 plus 9 equals 11. And our first step is to undo the last thing we did. Kind of like shoes and socks. We did the socks, then the shoes, and then when we undo them, we take the shoes off first. So subtract the 9 from both sides. And I have to do whatever I have to do it to both sides so that my equation stays balanced. This is called the subtraction property of equality. And that's my short version of that. Now, this gives me 0. And if we add that 0, we just get the W over 3. And the equal sign is still there. And 11 minus 9 is 2. And now I'm going to do the opposite of dividing by 3, which is multiplying by 3. Now, a lot of people get confused on how to go about writing this down. The best way to multiply by 3 is in parentheses on it with the numerator, because this really is 3 over 1. The 3's cancel out, and we get W is equal to 6. Now, it's important that you follow order of operations. Now, you could check your answer by substituting it back in. 6 divided by 3 is 2, plus 9 is 11. But we're going to go ahead and put our answer in. Let's get our answer going and get this guy done. All right, so I'm not going to go into the detail this time. I'm going to add 2 to both sides. So I'm going to add 2, and let me make it a little bit bigger. Add 2 to both sides, and I get G over 3 equals 4. And then I'm going to multiply by 3 on both sides. And G is equal to 12. This time we're going to subtract 2 and multiply by 3. If I subtract 2, I get B over 3. That's supposed to be a B. Put a tail on it. Is equal to 2. I subtracted 2 on both sides, and I get B by itself, so I have to multiply by 3 to get that to go. 3 simplifies with the 3. I'm actually dividing by 3 in the numerator and denominator, simplifying a fraction, or simply dividing by 3. 3 divided by 3 is 1. That gives me B equals 6. We're going to subtract 6 and then multiply by 3. If I subtract 6, I get V over 3 equals 3. And if I multiply by 3 on both sides, I get V equals 9. One way to think of this is that this could also be thought of as a proportion and that you're cross-multiplying. Cross-multiplying really is doing this. It is the exact same thing. V equals 9. Now this time it's on the wrong side. Wrong in quotes. but we're going to add 1 to both sides. So now a very common mistake is to just want to subtract 1 from both sides. You could do that, but it's not going to get you any closer to your answer. I want to add 1 to both sides so that I get the u by itself eventually. U over 2 is equal to 2. And now I'm going to multiply by 2 on both sides. Notice I could have switched these two. That using that property is called the symmetric property of equality. It says that if A is equal to B, then I can switch it and say B is equal to A. And that's called the symmetric property of equality. I just left it where it was. It just seems easier to me to just leave the U over here on the right, and it's equal to 4. Again, we're going to subtract 1 and then multiply by 2. So I'm going to get 2. I'm going to start doing it in my head. Don't need to write it out. This time I'm going to subtract 2 and divide by 4. Get 2. This time I'm going to add 1 and divide by 2 and get 2. Okay, now this time I've got 2k minus negative 2 is equal to 4. And remember, when you're subtracting a negative, it is the same as adding a positive. Lots of ways of thinking about this, but the reason is that if you take away owing $2, it's really the same as paying $2. So 2k plus 2 is equal to 4. And we're just going to subtract the 2 and divide by 2 and get 1. This one we're going to subtract 4 and divide by 2 and get 2. In this one, we're going to subtract 8 and divide by 3 and get 1. Oh, by the way, these are backwards. So not only is the equation in a different order than we usually see it, but also the addition. Now, switching these two is allowed because A plus B is equal to B plus A. This is called the commutative property of addition. Commute means to move from one place to another. So 3G plus 8 is equal to 11. And what I did from the first step to the second step is I used what's called the commutative. Notice that there's no N in the word commutative. It's like the word commute, where you're going from point A to point B. That's how you can remember it. The commutative property of addition. And that's what I used to switch those two. Now, I wouldn't have to. I can still subtract 8 from this top equation on both sides, and it doesn't affect anything. So I'm going to subtract 8 on both sides, and then divide by 3. Since 3 equals 3G, G is 1, and we're done. This time you're going to subtract 8 and then multiply by 4, so it's going to give us 16. In this one, we're going to add 14 and then divide by 7 and get 3. In this one, we're going to add 34 and get 5, and then we're going to multiply by 4 and get 20. Now I'm going to go ahead and write this down. This is negative 29 is equal to n over 4 minus 34. And I am going to add 34, because adding 34 is the opposite of subtracting 34. And of course, that gives me n over 4 is equal to 5. And I'm going to multiply by 4 on both sides and get my 20. Please do not grab your calculator. Lots of ways of thinking about this. But notice that 29 is really close to 30. And there's a way to use conjugation to make this a lot easier for yourself. So we're going to talk about conjugation in class, and hopefully you're going to be able to use it. Now I'm going to multiply by 4 and get my 20. This time we're going to subtract 13 and then multiply by 2. Since I have a decimal, I'm going to go ahead and write it out. It's n over 2 plus 13 is equal to 16.74. We're going to subtract the 13 from both sides. And we get n over 2 equals, and this is going to be 3.74. This decimal is really 0, 0. We're going to multiply by 2 on both sides. And we get n is equal to 7.48. If you need to, you can always just do a little arithmetic over here on the side. If you need to do it that way. If you can do it in your head, that's great. 7.48. Same idea. Now this one's getting a little more complicated. And in fact, you're going to want to do your arithmetic on the side most likely. If you can't see that that is 3.72 and then divide that by 2, it is kind of difficult. So it's a good idea to go ahead and write it out, especially since we're getting near the end here. So 2b plus 4.15 equals 0.43. And you're going to be tempted to grab that calculator, but please don't. Use it as a, if you don't use it as a crutch, if you use it as just a check, it won't hurt you. So notice that my 4.15 is negative and my 0.43 is positive. The thing is that when you're looking at a difference, because they have different signs, it's usually easier to write the larger number on top, since you're going to have to do a borrow and do the subtraction on the side. This is the arithmetic, and I like to keep it separate from the algebra, because you're really not subtracting 0.43 from 4.15. You're actually adding a negative, but it's the same when you take the difference and keep the sign of the larger. So I'm just going to do the difference. That gives me the 2, and I had to borrow from the 4, and that gives me my 7. Notice my decimals were lined up, and I have 3.72. But here's the thing. The larger number was negative, and the smaller number was positive. So this ends up being a negative 3.72. And it's really easy to make sign errors. So 2b is equal to negative 3.72. Now I'm going to divide by 2. And if you can divide by 2 in your head, great. If you can't, you can always do it on the side. 2 goes into 3.72. Again, if you just grab your calculator every single time, you're going to have to. And I guarantee when you get to college, the very first thing they're going to do is they're going to give you a thing called the AccuPlacer test. And the AccuPlacer test has questions like these, except you're not allowed to use a calculator. And you do not want to be trying to remember your arithmetic when you're testing to see what class you're going to get in. So subtract 2, we have 17, and 2 goes into 17 8 times, and we have 12 left, and that goes in 6 times. And remember that this is a negative number, so my answer is also negative. This is negative 1.86. Now I'm going to add 7 and multiply by negative 2 and get 2. If you need to see it, well, practice it yourself. You can try it yourself. I want to get this done. This time we're going to want to add 2 and then multiply by negative 2, and it's going to give us 0.4. 0.4 if you like. This one we're going to subtract the 4.5 and then divide by 4. Looks like we're going to have to write it down a bit. So I've got 0.5 plus 4j equals 13.3. Now, if I wanted to be very formal, I could switch these using which property? Do you remember? I'm commuting them. So it's the commutative property of addition. And I could do that, but I don't need to. I could subtract 4.5 because I know that's the last thing I did. And this time it's actually in the correct order. So I could do my borrow, and I'm going to end up with I'm going to borrow from this and make it a 12. And 5 from 13 is 8. And 4 from 12 is 8. And so I get 8.8. And I have 4j is equal to 8.8. And hopefully you can divide that by 2 in your head and get your 2.2. All right, finally, almost done. So we're going to add 7.09, and it's a good idea to line those decimals up. If you can see that it's going to give you 12, that's great. Because you see the 7 and the 4 gives me my 11, and then the 0.09 and the 91 add up to a 1. And so I've got 12, and divide by 4 and get 3. So if you notice it, that's one of the reasons for learning your conjugates, because sometimes you see them. You see 9 and 91 are conjugates, just like 9 and 1 are conjugates. This one, we're going to subtract 1.45 from both sides, and then we're going to multiply by 3. Again, I could switch these if I wanted to using the, remember, symmetric property of equality. It says that if A equals B, B equals A. But we'll go ahead and just leave it the way it is. 2.83 equals y over 3 plus 1.45. We're going to subtract the 1.45 from both sides. It's like we're going to have a borrow here. I'm going to have to borrow from that 8 and make it a 7. And that gives me an 8 and a 3 and a 1. Remember to line up your decimals. And now we're going to multiply by 3. Now you could do this in your head, and there is a trick to it, but I'm just going to go ahead and put it on the side. 1.38 times 3, and we've got 24, carry the 2. We have 9 and 2 more makes 11, and that gives us a 4, and we move the decimal 2 places. So 4.14. This one we're going to subtract 2 and divide by 3. That looks like we're going to get, it's going to be a little hard to do in my head. So I'm going to go ahead and write it out. 2 plus 3h. Again, we could switch these two. We're going to subtract the 2. Notice the decimal isn't showing, but it's still there. 3h is equal to 5.52. We're going to divide by 3. And h is equal to 3 goes into 5 one time, and then we've got 25 left. Can you see what I'm doing? 3 goes into 25 8 times, and we've got 12 left, and then we go in 4 times. So basically, I'm doing all the work, that we would normally do in here, but I can do it right there in my head. 5, 2. And what I did is I said 3 goes into 5 once, and then I subtracted it. In Mexico, a lot of times they don't write the 3 and do the subtraction here. They actually just do the subtraction in their head, which gives them the 2, and then they bring down the 5. Then they say, 3 goes into 25 8 times, but they don't actually do the multiplication and the subtraction on the paper. They just do the 24 in their head. So 8 times 3 is 24, and then they subtract, and they write down the 1, and bring down their 2, and 3 goes into 12 4 times. You can see that it looks a little bit neater than ours, and of course you don't use up an entire page doing a long division. So that is 1.84. Boy, we're going slow today for some reason. All right, so we're going to add 8 and then divide everything by 3. And this one is actually going to be, it looks like 6.16 maybe. No, yeah, 6.16. Now I'll just write it down. 6.16. Let me just double check my work. Add 8, I get 18.48. And then we're going to divide that by 3, and we get the 6. And then we'll 1, and then the 6. Yep. Hopefully you can see what I was doing there. We're going to subtract 2.95. Now this time, it's a little more interesting because when we do that subtraction, it's going to give us two negatives and they're going to get a little bigger or more negative if you like. So I'm going to go ahead and write it in. Can't imagine you're needing help with this, but you never know. Again, you're going to be very tempted to grab the calculator. Don't do that because basically I'm just adding 3. It's probably easier to just add up the pieces. So I've got the 6, the 1, carry the 1, and you get the 9, and it's negative. So we have 2k is equal to negative 9.16. We're going to divide by 2. And k is equal to negative 4.58. And let's double check. 2 goes into 9 4 times with 1 left over. 2 goes into 11 5 times with 1 left over. 2 goes into 16 8 times. And looks like we got 1 or 2 left. We can add the 6.1 and get the 8.7 and then divide by 3. And it looks like it's going to be 9.9, maybe. Let's see. 3q minus 6.1 is equal to 2.6. We're going to add the 6.1. 3q is equal to 8.7. We're going to divide by 3. And it goes in, 3 goes into 8 2 times, and 3 goes into 27 9 times, 2.9. Okay, we've got all sorts of things going on here. First of all, notice that that double negative is the same as a positive. Just like when you multiply two negatives together, you get a positive. We can think of it that way. So I've got negative 0.2 is equal to 3 plus 2d. We're going to subtract 3 from both sides. Notice that these have the same sign, and subtracting 3 is the same as adding a negative 3. That's a good way to think of it. So my 2d is by itself, and over here I've got negative 3.2. I'm going to divide by 2. I'm going to get negative 1.6 is equal to d. And looks like we might just have one more, hopefully. We subtract the 1 and get the 8.4, and then divide by 3, and we're going to get 2.8, I believe. Let's go ahead and 8.4 divided by 3 is 2.8. Oh, I did dash. That'd mess me up. And one last one. This time we're going to add 3.6 and then multiply by 2. So let's take our negative 3.47 is equal to u over 2 minus 3.6. Add 3.6, 0. And notice that it's upside down. The larger number, the positive 3.6, is on the top and the negative's on the bottom. But if I'm really tricky, I could subtract upside down, couldn't I? Draw my line. And I'm going to borrow from the 6 and make it a 5. And 7 from 10 gives me 3. 4 from 5 gives me the 1. So it's going to be 0.13, and the positives win. If you need to, you can always write it on the side, 3.60 minus 3.47. And do your subtraction over here. 0.13 is equal to u over 2. We multiply by 2 and get our 0.26. .26. Looks like we might be done. All right, we made it. It certainly took a while, 20 minutes again. I hope you all will continue practicing and really get great at your algebra. This is a good way to do it, is just to practice. Use your calculator only when you need to check your work, and good luck. Bye.